All right, good morning, Logan. It's Tuesday. Let's see, March 24th, and we're at it again. All right, so this time we're going to be talking about rectangles, which is a type of parallelogram. This parallelogram has three characteristics. Actually, only has two characteristics I really need you guys to know. And the two characteristics are as follow. Number one, the four angles of the rectangle are right angles. So, for those of you that are not sure what that means that this angle right here is a 90-degree angle, and this angle here is a 90-degree angle, and this angle here is 90, and this angle right here, that is also a 90-degree angle. So those four angles right there are going to be 90-degree angles. Now, the second property that you guys need to worry about is number two, the diagonals of a rectangle are congruent. Now, the diagonals being D to B and A to C, those things are congruent. So all of this right here is congruent to all of this right here. But this is where it gets tricky, because if AC is congruent to DB, but we also know that for all parallelograms, because look at statement 3, rectangles are special parallelograms. Because this is a parallelogram, you can also say that this piece of the diagonal is congruent to this piece of the diagonal because the diagonals bisect each other. But because the diagonals are congruent, you can also say that this piece is congruent to the other three, including that piece right there. So all the pieces are congruent to each other, all the diagonals, I should say. So that right there, those are the three, the two main properties are 1 and 2. The angles are 90-degree angles. But then the last one is that the rectangles are special parallelograms. That's going to be an important component to us. All right, so we're going to jump into this problem. Here's our example. The diagonals of rectangle ABCD, right? So the diagonals AC and the diagonal DB, those diagonals intersect at E. So that means this point right here, this point we're going to call E. So I'm going to call this guy right here E. I'm going to say that's point E. Now, given that the measure of angle EAD, all right, EAD. So given that this angle right here, okay, so that's the angle we're talking about. Given that this angle right here is 62 degrees, what I need to do is find out all these other pieces of information here. But I have one more thing, BD. So BD, that whole line right there, B to D, comes out to 18. So from here to here is going to be 18. Okay, so from there to there is 18. Now I'm going to erase that because it's going to kind of get in the way, but we'll come back to that when we start talking about segments and diagonals and pieces of the lines. So we got that the angle the angle EAD is 62 degrees. My first question, question A, is find angle CAB. So CAB, this angle right here. I need to figure out what this angle is. Now the good news is that those two angles right there, we know have to add up to what? It says it in number 1. It says the first characteristic, the four angles are right angles. So we know that these two angles here have to add up to 90 degrees. So that means this angle right here is going to be 90 degrees minus the 62 that is already there. That means our answer for problem A, our answer for A is going to come out to 28 degrees. So if I wanted to, I can write 28 degrees right here. Okay, 28 degrees right here. Moving on, question B. Angle BCA. BCA. So BCA. All right, so I need this angle right here. All right, now here's the good news. Because it's a parallelogram, we now know, or we do know, that these angles are congruent to each other using the alternate interior angle theorem. So I know that this angle here is 62 degrees. So I now know what BCA is. BCA comes out to 62 degrees. Notice kind of just opposite alternate interior angles. And then DCA. DCA. Okay, so now I got to figure out this angle over here. Once again, good news is that this angle, I know that these two angles together have to add up to 90 degrees. So then I know that this angle is going to be 90 minus 62, which is not a coincidence, is going to be the same exact thing that you got over here. Okay, so this guy here is going to be 28 degrees. All right, so that takes care of the angles. Now, if you wanted to, you can find all the other angles. Because this is an isosceles triangle, because the sides are the diagonals are congruent to each other, you could figure out all the other angles if you really wanted to. Let's go to BE. So B to E, we need to figure out how long this thing is right there. Let me use a different color. All right, so we need to find out how long B to E is. So this thing right here. Unfortunately, I don't know how long BE is. I only know that BD is 8. There it is. I know that BD is 18. So from that point to that point is 18. Now, since diagonals bisect each other, this guy right here has got to be half of 18. So that's got to be 9 right there. So I now know that BE is 9. Next, find AC. All right, now AC is this entire diagonal. Now, since the diagonals have to be congruent, I know that AC has to match whatever BD is. So this guy right here, AC is going to equal, that's right, 18. And then finally, E to A, so E, oh man, I just made this worse, from E to A. So from E to A, let me get those answers back in there. So we got AC is equal to 18. From E to A, right here to here, that's going to be congruent to this guy over there because they're all congruent. Remember, the diagonals or the pieces of the diagonals are congruent to each other. So we have E to A is equal to 9. All right, if you get the chance, take a look at the homework assignment. It's exactly like this problem right here. It's a different version of it. 6 questions. See if you guys can answer them for me. If you have any questions, please contact me via email or text. You can also hit me up on Google Classroom. I hope all is going well. Day 2 of week 2 down in the books. Have a good one. I'll talk to you guys on Wednesday.